So my name is the Math Raccoon, and I will be doing a lesson on the sine and cosine ratios. If you don't know what that is, get familiar with SOHCAHTOA, and it's for right-angled triangles. We are going to be focusing on the sine function and the cos function for this lesson. Sine, cos, and tan are primary trig functions. And we need to discuss unit measurements. We have a diagram which locates theta, adjacent, opposite, and hypotenuse. We also have inverse trig functions. And let's begin today's lesson. So here I have a little cheat sheet. You can refer back to SOHCAHTOA. Sine equals opposite over hypotenuse, cos equals adjacent over hypotenuse, and tan equals opposite over adjacent. We also have theta and its labeled sides, adjacent, opposite, and hypotenuse. And for this question, in each triangle, calculate sine A and determine the angle of A. Alright, so we have this angle right here, that's theta, so this would be opposite, and this would be hypotenuse as well, and then this would be adjacent as well. So let's mark that, opposite, hypotenuse, and adjacent. So we're going to input the values. So we need sine angle A. We're going to input the values of opposite and hypotenuse. So 8 centimeters over 13 centimeters. Then we have angle A. We're going to take the inverse of the sine function with the fraction of 8 over 13. Then we have angle A would be 37.98 degrees. When rounded, angle A is 38 degrees. And we'll do a therefore statement. With this therefore statement, the value of angle A is 38 degrees. 38 degrees. And we will circle both answers in blue. And moving on to the next question. Okay, so again we have angle theta with opposite here and hypotenuse there, as well as adjacent. So we are going to be labeling them. And then opposite. So we are going to take the sine of angle A. We're going to input the values of opposite and hypotenuse. And then we have angle A. We're going to take the inverse of the sine function with the fraction of 3 over 9. And then we'll go angle A is 19.47 degrees. And then rounded to its nearest degree would be 19 degrees. And then we have our therefore statement. The value of angle A is 19 degrees. Sorry, we're going to circle both answers in blue. Moving on. So we have adjacent it's this side length touching theta. We have hypotenuse, which is the longest side. And then we have opposite, which is from across. Okay, so we have sine angle A. We're going to input the value for the opposite side and the hypotenuse side. Then we'll go angle A. We're going to take the inverse of the sine function with the fraction 4/11. And then we have angle A being equals 21.32 degrees. And then angle A rounded to the nearest degree is 21 degrees. And therefore, the value of angle A is 21 degrees. And now we're moving on to the cos function. So we have our adjacent side, then we have our hypotenuse, and then we have our opposite side. And so cos theta equals adjacent over hypotenuse. So we are going to put cos angle A and put in our values for the adjacent side and then the hypotenuse side. Angle A equals cos, the inverse function of cos with the fraction 14/17. Angle A being 34.56 degrees. When rounded is 35 degrees. And then we have our therefore statement being the value of angle A is 35 degrees. And we will circle both answers in red. Moving on. So we have SOHCAHTOA formula. We have opposite side. We have adjacent side. And hypotenuse side. Sorry, we have opposite, adjacent, and hypotenuse. And then we have cos angle A. We're going to put the values of adjacent and hypotenuse. Angle A will take the inverse function of cos, 7/9. And then angle A would be 38.94 degrees. When rounded, 39 degrees. And then we will take our therefore statement. The value of angle A is 39 degrees. And we will circle both answers in red. And moving on. So we have the adjacent side. We have the opposite side. And then we have the hypotenuse side. So we have cos angle A. We will do the value of the adjacent over the value of the hypotenuse. Again, we have angle A, and then we'll take the inverse function of cos with 5 over 11. Angle A being 62.96 degrees. And then angle A being rounded to the nearest degree of 63. And then we have our therefore statement. The value of angle A is 63 degrees. And thank you very much. I hope you found this helpful. This was the sine and cosine ratios, and we are just using the sine and cos function of SOHCAHTOA to find the value of angle A. Thank you very much. Have a great day.